morning to all. I'm going to introduce you to the inert gas system which is used on tankers particularly. I know that inert gas is nothing but the exhaust from the boilers, which is known as boiler fluid. And then it is introduced into the tanks to dilute the atmosphere so that it is brought below the flammable range. Once the atmosphere is kept below the flammable range, the chances of fire and explosion are almost nil. So let's take a trip into one of the ships, so the inert gas systems, how they are fitted. Next, the objectives of inert gas is number one, because the regulations require IMO regulations. Then you have types, that is the flue gas, which is a gas which comes out from the boilers and cleaned and made into inert gas introduced into the tanks. Then what is the benefits of this inert gas? This is what we are going to study now in these few presentations. Next please. Now this, as you know, is a regulation by SOLAS, Safety of Life at Sea, is what requires an inert gas system on ships. Next. Now you can see tankers are divided into crude tankers and product tankers, which carry the products, that is, say, kerosene oil and naphtha, water spirit, which are all byproducts of crude. Now, this is what is carried in tankers. The requirement for inert gas, as you can see, is all crude tankers about 20,000 in weight, and all product tankers about 30,000 in weight. They are required to be fitted with inert gas systems. Next. What are the hazards of petroleum? Now, it's not the petrol which catches fire, it is the vapors given out by the petrol which mixes with the air in correct proportion and becomes flammable provided a spark is introduced into it. So it's highly flammable, it's highly toxic, which means it can affect your nervous system or you can even be dead. That's the meaning of toxicity. Now, flammability. First, let's start with flammability in inert gas systems. If you see a property of a substance to ignite, basically it requires a source of ignition. Even a static charge can be a source of ignition. Next, I can see there is something called a flammable range diagram. You can see in these diagrams, which is going to follow that. It's not all mixture of petroleum vapor and oxygen which can catch fire. They should mix in the correct proportion. Then only it becomes a flammable mixture. And therefore, what is this proportion? You can say roughly it's about 1% to 10%. In other words, if I have around 1% of hydrocarbon vapors mixes with the atmospheric air and anywhere up to 10% of hydrocarbon vapors mixing with the atmospheric air, only that is flammable. Anything below it is not flammable. Anything above it is not flammable mixture. So you can have the mixture below the lower flammable limit, which is not in the flammable range, or you can have one above the flammable limit, not in the flammable range. Now let's see this in a diagram form. Please. You've got the lower flammable and upper flammable. As I said, 10% to 1% mixture in air is what is flammable range. Here you can see the diagram. Now you see on the left is how much of it is hydrocarbon. Here is oxygen. Now you can see that minimum you require 10% oxygen for a fire to take place. Anything about 10% and anywhere between 1 to 10% of hydrocarbons. That's shown here in the checkered lines. Only in that mixture you can have a fire. And all other things outside this checkered line is quite safe. This much oxygen, this much hydrocarbon, you cannot have a fire. I take an example here. 10% oxygen, 4% hydrocarbon. You are not in the flammable range. Therefore, you cannot have fire. Therefore, to have a fire, you have to come within these checkered lines. That is what is called flammable range diagram. Next, please. You can know basically what is called fire. You need heat, oxygen, and you need fuel. If you take off any one of these, you cannot have fire. You need all the fire. Next, please. That's the fire triangle which I was talking about. Fuel could be any gas, liquid, or solid. Constitutes fuel. Heat, as you know, temperature. And more you heat, more chances of fire. Next, please. Oxygen. Maximum oxygen contained in air is 21%. Now, for us, as you know, you require anywhere around 19% oxygen. And for a fire, 10% oxygen is what is required. Anything below means difficult to sustain a fire. Minimum 10%. Next, please. Here you can see the fire triangle. How heat and fuel take part in a chain reaction. Next, please. So, theoretically, as I said, any mixture which has less than, say, 11% oxygen will not support combustion at all. You cannot have fire. But for safety reasons, they are keeping regulations require 8%, which means in any inert gas system, you must have less than 8% by volume of oxygen. Then you cannot have fire, you cannot sustain. And next, please. So, what is inert gas? Now, basically, you need inert gas on the ship because then it can be filled inside your cargo tank in an empty space. And then you can ensure that the atmosphere becomes diluted, lacks of oxygen, and therefore you cannot have fire, therefore explosion inside the cargo tank. So how do you get inert gas on ship? Either you generate it on board, which is expensive, use your exhaust from your boiler, which is available as long as your boiler runs, or you can get it from a shore. If you are in port, get it from a shore, fill up your tanks. This is basically how you get inert gas. Next, please. So, what are all constituting inert gas? Argon, krypton, neon. These are all inert gases. But basically, on ship, your inert gas is going to be nitrogen. Air contains maximum amount is nitrogen. If you take off oxygen, it's going to contain nothing but mainly nitrogen. So if you don't have inert gas, you will buy nitrogen from the shore. Next, please. So inert gas is basically the definition of inert gas. It's a composition of gases which does not have sufficient oxygen to cause a fire. As I said, it is not the oil which will catch fire. It is a vapor given out by air and mixed with air. That is what creates a fire, provided the vapor and the oxygen are in correct proportion. Otherwise, you cannot have a fire. So, inert gas on board the ship you get from an inert gas generator, which is fitted in the engine room, or you can get it from your boilers. After the boiler doesn't work, the exhaust which comes out is starved of oxygen. It is known as flue gas. Only when it comes to cargo tank, it will be known as inert gas after it is cleaned. Next is, so an inert gas is distributed into a plant system, a distribution system, and this is fitted on the ship. Let's see the plant, basically what it is. You see an inert gas plant. It takes the boiler flue gas or the gas from the boiler, cools it, cleans, pressurizes, and then supplies it into your cargo tank through the inert gas plant. Then only you say that the tanks are all pressurized with inert gas. You must have positive pressure in the tanks. Positive pressure means it's slightly above atmospheric pressure, so that the outside air will not be able to enter your tank and mix with your already whatever vapor it is. That is the meaning of positive pressure. Usually it will be above the atmospheric pressure when introduced into the tanks. Next please. The distribution system consists of piping, valves, and all fittings connected to the pipelines and valves, which is on deck. That is what is called distribution system. So an entire plant has got a system fitted to your deck till it goes and enters your tanks. Next. So you can see that it has got a plant plus distribution system. Plant is generally the engine room, distribution system is on deck. Next please. In oxygen throughout the atmosphere of the tank should be reduced. Inside your tank, there is no point if you have inert gas but oxygen content is too high. There is a saying that improper use of inert gas is worse than having no inert gas at all. So you must have less than 8% by volume of oxygen. Otherwise, the whole exercise is a failure. It's a waste. Next. You can see the inert gas system is basically what it is. That from the boilers here, engine room, it's an uptake, enters a scrubber unit where it's washed and cleaned. And with the help of fans or blowers, it's delivered to your cargo tank after passing through a deck seal unit. Now the purpose of that scrubber is to clean the tank, convert your flue gas into inert gas. Because there will be a lot of dust particles, sulfur particles generated in the engine room. Now once you enter the deck seal, you can see it is known as a seal because it can only allow your inert gas to bubble through the water and move out and enter one way. It will not allow the cargo vapor from the cargo tank to come back to the engine room and form a dangerous mixture in the engine room. That's the whole purpose of this deck seal unit. You can see it passes straight into the cargo tank. Now, if there is excess pressure in the tank, naturally it has to be released. This will be released through what are called as pressure vacuum valves or pressure vacuum breakers. It's nothing but setting it to an above atmospheric condition. If there is excess pressure, the valve will open, release to the atmosphere. If there is excess vacuum, which is also bad for the tank. The vacuum side will open, allow the outside air to come into the tank. So we would better accept that condition rather than having a vacuum in the tank or an explosion in the tank. These are the purpose of PV valves, which is connected to each tank as well as a PV breaker, which is connecting the entire system. So if your tank fails, your PV breaker should open to release the pressure. These are called PV breakers. Next, please. This is basically the diagram, block diagram. You can see boiler fluid gas from engine room goes to scrubber, gets cleaned, washed, two blowers. You can use one or two. Takes it, goes to a deck water seal to various isolating valves. This is a pressure active valve goes into the tanks. In case it is improper, this valve can shut, recirculate the inert gas till it is once again all right, cleaned properly, regulated, and automatically this valve will open, send it directly inside your carbon tanks. So this is a kind of typical arrangement of IG system used on ships. Next, please. This is known as the boiler flue gas. There is a valve called uptake valve, and it just first comes out of the boilers. Next. Now this is the scrubber unit. As I said, when it first comes from the boiler, it will enter, get cleaned, washed, all sulfur particles will be reduced, oxygen will be under control, it will go, blower will suck this inert gas. Next, please. So the flue gas passes through the scrubber, enters at the bottom. This is the water seal. While it enters here, water is being sprayed on top of it. There's a demister here. And it will go through this so that it is cooled by seawater clears the and enters the tank. Next, there are two blowers fitted to suck this inert gas from your scrubber into your cargo tanks. One on port side, one on starboard side. Next, you can see this blower. The capacity of the blower is 125% more than the pump capacity. Yes, you may be knowing that these are entering pumps from where cargo is being discharged. If this capacity is anywhere less than the pump capacity, it means that what is coming in is lesser than what is going out. That's going to be dangerous. So as the cargo goes, the blower should also fill up the space on top, and therefore it should have a capacity higher than the pump capacity of the ship. So if the cargo is going at 1000 cubic meters per hour, the gas should fill up the tank at 1250 cubic meters per hour, something more than what the cargo is going out. Otherwise, your tank can get pressurized or vacuumized, anything can happen if there is not sufficient pressure. Next. That's it. So there may be two blowers to meet this. Some ships may have one blower, right? There could be one or two blowers. Next. There is a regulating valve which makes sure, which I showed you the diagram, that it will control and find out whether the gas coming out from scrubber unit has got correct pressure. If not, it will recirculate and automatically open only when the gas is as needed by you. So in other words, if you find that it is not clean, sulfur content high, that means you don't want it. You still want to clean it again. It can be recirculated once again. For that purpose, you are regulating that. Next. So your deck seal, as I said, is a unit which you saw in the diagram. It can allow the inert gas to bubble through the water and enter the cargo tank. Only one way. It does not allow the cargo vapors to come back into the engine room. It forms a seal. If I introduce gas underwater, it can bubble and come out. But if I introduce gas above the water, it cannot bubble and enter inside. That's the basic concept of deck seal unit. It allows inert gas to enter from your scrubber, go into the cargo tanks. but it will not allow cargo vapors to come back into your engine room, which can become highly dangerous situation. Next, so the seal is a safety feature. As I said, it is to make sure that you have kind of non-return system. Next, please. There are types of deck seals. You have wet type, semi-dry, dry type, but generally you will find ships are fitted with this wet type. These are predominantly found. Rarely you will find a dry type. Next, you can see here, this is how a wet type works. Inert gas enters, it bubbles through the water, comes, goes up. If there is back pressure in the cargo tank, the vapor can merely push this, but it cannot bubble through this, go back to the engine room. This is the idea of having this. So it allows inert gas to go bubble through this water since it's like that, go to cargo. But it will not allow the cargo vapor to come and go through this and go to the engine room. That doesn't happen. That's why it is called a seal. Right, next. This is a semi-dry type. You can see it has got a vacuumized system here, the injury effect. If it finds that back pressure comes from your cargo tank, it immediately pushes this aside and prevents the gas from going through this. So it's still a deck seal, but if the gas from the cargo won't come, you can see it going entering the tank. But from the engine room side, see, from the cargo side, this eventually acts, pushes water here and prevents the gas from entering inside. Right, next. This is a dry type, very rarely found, where in case of any pressure fall, automatically a tank is kept filled with water. It will fall down and prevent the gas from passing through it. So very rarely you will find dry type ships. Next. This is a non-return. In addition, they provide non-return. As I said, this will be on deck to prevent cargo vapors. In addition to deck seal, you have a non-return, so that cargo vapors will not come back to your cargo tank, which is very important. Otherwise, you can have a dangerous situation in the engine room. Next. This is again an isolation valve on deck, which is the first barrier. In case you want to isolate completely the deck from engine room, shut this isolation valve. It's especially useful when you are laying up the ship for repairs and so on. Next. Distribution of decks. You have a PV valve, you have a main line running all around on deck. Can even be vented. You have vent valve to atmosphere in case you want to vent it to the atmosphere. Next. Again, the distribution, as I said, individual lines. We're going to each cargo tank to supply inert gas. What happens if the tank gets pressurized? PV valve is open. Each tank has got a PV valve. What happens if this PV valve doesn't work? It's connected to a PV breaker. The PV breaker will open, release the pressure before you have an explosion in the tank. Right, next. Here's the deck distribution, not very clear here. The white lines are the lines which are carrying the inert gas. Each cargo tank, you can see, each cargo tank is connected by this deck line in the inert gas system. A bit unclear in this diagram. Right, next please. This is the PV valve. As I said, each tank is fitted with the PV valve. This is a PV valve which works, which is set to a particular pressure, particular vacuum. So, in case of excess pressure, it will release, and the vacuum side will release, and let outside air come in, rather than have a vacuum inside the tank. Right, next. This is a diagram of a typical PV valve. You can see this will just lift in case of excess pressure, release the pressure in the atmosphere. In case of vacuum side will open, allow outside air to enter the tank. This is typically what is PV valve. Next. So when loading cargo tank, if you have high pressure, normally your PV valve will open. You can also release the port by means of a riser on the mast. So as you are loading the cargo, all your gas can evaporate, plus the inert gas in the tank, to a mast, to the top of the tank. Because now modern regulations require a vapor line to be connected to the shore, especially countries like Japan and US. They already started enforcing very strictly that all these vapors should not go to the atmosphere, but should go to the shore. Because what they do with it is their business, but normally they again convert this vapor back to oil and they can use it. Next. So, what is the role of these PV valves and the high velocity valves? Nowadays, you do not have high velocity valves, but you can see on olden ships they had high velocity valves. Next. Now, this is a typical high velocity valve. When loading the cargo, you can see this is an orifice. At Bernoulli's effect, the gas which comes out is shot right into the space, almost 45 meters high. So the vapor will not remain anywhere near your deck, but will be shot through this cone high above your deck level, so that the crew is working down. They will not feel the effect of this gas on deck, so it will shoot it well high, which used to be known as high velocity valves. But after the introduction of inert gas, they have discontinued these high velocity valves since it's not supposed to go anywhere except through the mast riser. Or even better, now it is supposed to go to the shore through a special line, as I said, called vapor emission control line. New regulation as required by convention. Next. So this is a good diagram of an inert gas generator. That is, if your boiler is not there, you can get it from a generator. More expensive because you have to particularly burn diesel and produce inert gas. So no other alternative unless you buy it from shore. Next. So basically, what is the benefit of this inert gas on ships? Number one, it reduces fire hazard. And number two, it reduces your cargo discharge time. How does it reduce cargo discharge time? Because of the pressure created inside the tanks. The cargo pumps find it easy. They have a good suction and therefore are able to discharge more efficiently. So this is a whole inert gas system which is now mandatory, as I said, on tankers for specific sites.